we are going to cover the sprinkler system design. Most of the components we have already discussed in the previous sessions. To start with, we have a index which is showing definitions, classifications of building occupancies, design density and AMO, area distribution, pressure and flow requirement for sprinklers, pipe size of sprinkler as per schedule, and hydraulic calculation as per NFPA performa. System balancing of water supply through orifice plate and the pump selection. These are the areas which shall be discussed and explained in the oncoming slides. What we see over here, the sprinkler system design, it can be designed in two ways. One with the pipe schedules or hydraulically calculated. Pipe schedule is decided according to the system pressure and the required flow. Sprinkler discharge density and the estimated area of coverage determine pipe size. Hydraulically calculated an engineered approach to match the fire hazard to potential water supply pressures and volume. Most automatic sprinklers today are hydraulically calculated. These calculations are generally calculated by software. In market, there are various kinds of software available which may directly calculate and size the pipes. We in NILSoft also have a software to calculate the hydraulically pipe size of sprinkler systems. A copy of this may please be obtained from our system department. The name of software is Elite. What are the general requirements of sprinklers? General requirement of sprinkler systems are standard, pendant or upright sprinkler, sidewall sprinklers, extended coverage sprinklers, open sprinklers, intermediate or rack sprinklers, early suppression and fast response sprinklers, and large drop sprinklers. Most commonly used in the building systems are the standard, pendant and upright and the sidewall sprinklers. Extended coverage sprinkler also used where the area required to be covered is slightly more than the standard sprinklers coverage to save a number of sprinklers. Open sprinklers are generally used for the purpose of cooling the surfaces like medium velocity spray system and high velocity water spray systems. Intermediate or rack sprinklers are used in the storage areas. Early suppression and fast response sprinkler, these are also having its application in the storage area. The large drop sprinklers, these are generally used on the spilled flammable liquids. Here we are going to discuss further now the design approach, spacing, location and the installation of sprinklers. Design area and density of applications. As we discussed and learned from the definition, what is the designed area? Designed area is the area where the sprinklers are to be provided, and those are on the basis of AMAO, approximate maximum area of operation, and those are decided according to the type of hazard, namely what we see over here is the light hazard. Light hazard, the design density of the water discharge shall be 2.25 liter per minute per meter square over an assumed area of operation covering 84 meter square. Ordinary hazard is the density of water discharge shall be at least 5 liters per minute over an assumed area of operation covering 360 meter square. Distinctly, we see the difference between the light hazard density and the area coverage and the ordinary hazard density and the area coverage. We see over here 2.25 liters per minute per meter square covering only the 84 meter square area. Similarly, 5 liters per minute per meter square area covering the 360 meter square. That is the main difference between the light hazard and ordinary hazard sprinkler design systems. Similarly, for the high hazard, we are having a different requirement which is noticeable over here, that it requires 10 liters per minute per meter square covering the area of 260 meters square. This is the summary of what we have seen over here. Light hazard density 2.25 meter per meter square per minute and 84 square meter area. Similarly, those things are explained over here. What we see that the general requirement. What is the general requirement? All the measurements between the sprinklers or of areas covered by groups of individual sprinklers shall be taken in the horizontal plane. A sprinkler shall be installed upright or pendant or required under the circumstances with the reflector parallel to the slope of the roof, ceiling or pitch line of stairs. Where the slope of roof is greater than 1 to 3, a line of sprinkler shall be fitted to a apex. There is a row of sprinkler at not more than 75 millimeter distance radially therefrom. What does it mean? It means that although the pattern of discharge what we see is this cone type sphere, but the design areas when we consider on the horizontal plane, and the sprinkler installed upright or pendant under this deflectors parallel to the slope of the roof. Means if there are inclined roofs, it has to be installed according to the line of roof's inclination. So theoretically, when we draw a pendant or install a pendant sprinklers, it will be having a slope and discharging on the horizontal surface. These are required. In this case, although we have given a covering areas which may reduce with the placement of the sprinklers, those things will be explained further when we go and see in the oncoming slides what should be the spacing of the sprinklers and how much each sprinklers for different kind of hazard shall be able to cover the area. This is what we had discussed in the previous slide or explained over here. See the maximum area coverage per sprinkler for the light hazard. The sidewall 17 meter square. What is the sidewall sprinkler? The sprinklers installed on the wall. It will having a horizontal throw with the deflector plate so that it can cover the surface area. And other type, what is other type? Means pendant and upright. Those are the sprinklers which shall be covering 21 meter square area per sprinkler. And generally, while placing those things for the light hazard, the spacing of the sprinklers must not be increased or more than 4.5 meter for sidewall, as well as the same dimension 4.5 meter for the upright and the pendant sprinklers. For the ordinary hazard, you will notice the sidewall sprinklers are covering less area than the light hazard. This is 9 meter square and 12 meter square for the other, that is vertical and the pendant sprinklers. Maximum distance between the sprinklers on range pipes and between the adjacent rows of sprinklers for the ordinary hazard must be 3.4 meter, and with the standard spacing it is 4 meter. That is for, this is for the sidewall sprinklers, and this is the standard spacing. So when we come to this is the area limitation. What does it mean, area limitation? See, the area limitations means the area which can be operated by one installation. It means an area of a sprinkler system covering 10,000 meter square area on one floor must be controlled by a separate installation wall. If the area is increased, you have to provide another control wall. This kind of a spacing may be changed, means to reduce the area coverage within this limit for any length of the pipe, but it must be installed with a separate installation control wall. Similarly, the area coverage for the ordinary hazard is 12,000 meter square area, and high hazard is 9,000 square meter area, and storage hazard is 9,000 square meter area. Floor areas of mezzanine floor shall not be included in the above area restriction. What does it mean? When we are having certain mezzanine floors within this area, it should not include with this area. It means the horizontal surface area will remain this only, irrespective of the mezzanine floor over there. In case of multiple hazard or mixed occupancy, like high hazard with ordinary hazard, respective limits shall prevail. Means there are certain areas, very large areas may have certain offices or low hazard occupancies, and part of it might have a high hazard occupancy or the ordinary hazard occupancy. Should not be more than the maximum limit of those areas, like what we see over there, 12,000 square meter for the light and ordinary hazard. See, these are the following clauses are applicable for the design of the systems, which we already discussed and re-explained over here, that light hazard protection area shall not exceed the figures as below: 21 meter square light, 12 meter ordinary, and 9 meter. And similarly, the sprinklers position accordingly: to be followed. So what we see over here, the standard sidewall sprinklers. These are the area coverage by the size sidewall sprinkler for its respective type of hazard. And these are the guidelines which we see has required to be followed and are so explained over here, which must be abided with while designing the sprinkler system. See, this is an example of calculating the residual pressure for light and ordinary hazard occupancy. What is the residual pressure? Residual pressure is the pressure at which the sprinklers should discharge to obtain the flow of 2.25 liter per minute per square meter area and the 21 meter square area it must be covered. Having its a orifice factor or orifice size already explained, that is calculated with these equations. This K factor, this factor actually is known to us while selecting the sprinklers, and generally this is the K factor used for the light and the ordinary hazard. And having this calculation solved, we may find a residual pressure of 0.4 bar. What does it mean? It means at the remote sprinklers, if I apply this pressure, I will be able to get 2.25 liters per minute per meter square spray covering the 21 meter square areas. This is the area to be covered by the light hazard sprinklers, and this is the density. Similarly, the application for the ordinary hazard will also prevail. So occupancy classification, this is the simple design calculation we have made. Density 0.15, this is which we have taken actually from the NFPA. But generally we are working as per the TAC. TAC has already given the area to be covered for light hazard at we had seen 84 meter square area, and for ordinary hazard, which we already seen over there, they're different. NFPA is a bit different, and as we are not working according to the NFPA, this is an example only shown over here. Further explanation may be obtained when some designer wants to go for the NFPA system design and can contact Mr. Habib Ahmed for further clarification and the details. Sprinkler system piping. See, this is the schedule of piping. What is the meaning of schedule of piping? With the standard design practice, we have scheduled the pipes which can receive the number of sprinklers installed on each branch, each size of the pipes. Here, this is the table. This is for steel pipes and this is the copper pipe. You will notice something. Copper pipes can take more number of sprinklers than the steel pipes. The reason is very clear. These are on the basis of internal pipe diameter. The steel pipes are having a smaller internal pipe diameter than the copper. Therefore, the number of sprinklers, the same size of the pipes, may be more. Explains the 1 inch dia pipe. It can have 2 sprinklers mounted on it. When the number of sprinklers are 3, you have to increase the pipe diameter to 1/4 inch. When there are 5, we have to go. And likewise, we have to follow the cumulative number from start to end. And at the end, we have to size the total number of sprinklers installed on the pipes, which can be taken with the given size of the pipes. This is the same table which is reproduced from the NFPA or explained over here, and this is for light hazard and this is for ordinary hazard. For all our design purpose, we are following these tables. These are in the compliance with the NBC 2005 Part 4